Good day. In this lecture, we go to chapter 1, Matlab overview. In Matlab, just like C, the variable names must begin with a letter, and the rest are made up of letters, digits, and underscore in any combination of these three. The variable names in Matlab are also case sensitive, just like C. For example, capital A and lowercase a are completely two different variables. And in Matlab, of course, the length of the variable can vary from 1 to very long. 1.2, arithmetic operations. This symbol is for exponentiation, a raised to the power b. Of course, this is the syntax, how you type in Matlab. Of course, in our case, is in the Octave compiler. Multiplication is asterisk, right division, left division, addition, and subtraction. Let's just quickly go to the Octave compiler. You can resize the window, dragging this line to the left. Preferences, you can change the font size and font type. Command window. Let's say the font size, make it bigger. Two raised to the power 3. If you do not assign the results to any variable on the left, the default variable is always going to be a and s, unless you put a variable where we want to keep the results. For example, 2 to the power 4. Three over 4 left. This is right division. It's different from left division. This is 3 over 4. This is 4 over 3. Of course, subtraction, addition and subtraction, and also multiplication. The same symbol as in C programming. Order of precedence. Scala is a single number, and the scalar variable will contain a single number. For example, x equal to 8. So x is the scalar variable, and 8 is the single number. When you have an expression or statement, parenthesis has the highest priority. If you have multiple parentheses, the innermost pair has the highest priority and has to work your way outwards. Second priority is the exponentiation, left to right. For example, 2 had 8. It's 2 to the power 8, not 8 to the power 2. Okay, left to right. Third priority is multiplication and right division. These two are equal priority or equal precedence. It's given to be left to right. For example, if you have here 2 times 3 divided by 4, so it's going to be, these two are equal priority, so left to right has to be 2 times 3 divided by 4, not the other way around. And the fourth priority is the addition and subtraction. These two are equal precedence, also the operation is left to right. 1.4, managing the work session. CLC is basically to clear the command window. Clear is removing all will remove all variables from memory. You can also be selective, clear only, for example, variable 1 and variable 2. The other variables will remain in memory. As this, you can check whether this variable exists in memory. Quit, of course, stopping Matlab, in our case, quitting. Octave, who lists all variables in memory, who's just a detailed version of who. The full colon is used to generate regularly spaced elements. Comma is used to separate elements of an array. Semicolon has two uses. One is to suppress screen display. The other one is to denote a new row. Ellipsis, the three dots, is used to continue to a new line. Let's go to the compiler. Clear is clear memory. So all these variables will disappear from the workspace. Memory is clear. CLC is clear screen. What's the use of full colon? Let's say I want to generate a row vector. There's a simpler way of doing this using the full colon. Basically, you have a for loop, implied for loop, starting from 1, step of +1, end at 6, stop at 6. Details will also come in the next chapter, chapter 2. What's the use of comma? When we generate array elements, to separate between the elements, we can use blank, one or more blank spaces. One blank space is enough. Or you can use comma to separate the array elements. Comma. It can be a blank there. There's no problem. But normally, to make it pretty, just get rid of the blank. So that's the use of comma, to separate between array elements. What's the use of semicolon? So semicolon has two uses. One is, for example, to suppress the output. You do not see the display. The rest, without the semicolon, you have a display of the output for Y in this case. The other use of semicolon is to go to a new row when we generate a matrix. For example, normally matrix, capital letters. Let's say first row. To go to the next row, semicolon. This is going to be second row, third row. So I have a matrix. So to go to the next row, we use the semicolon. Ellipsis. What's the use of ellipsis? Let's say I have a long calculation here. Of course, in this case, it's not that long, it's just an example. I'm running out of space here. I need to go down. You cannot do this. If you do this, it will calculate x. You get 8. Continue next line. See? There's no execution of the statement. Let's say I'm running out of line here. Going down. Now, if I hit enter, then it will calculate all this. This is basically to continue to a new line. Use the ellipsis, the 3 dots. Predefined constants. NS is a temporary variable. It contains the most recent answer. So whenever you do computation, you do not assign to any variable, then the output is going to be assigned to always a and s. I and j, they are equal to square root of -1. NF is infinity. None is not a number. Pi has a value in Matlab. Clear the screen, CLC. So the result is always assigned to ANS unless you specifically say keep the result in variable A. I has a default value which is square root of -1. It's a complex number. The real part is 0, the complex part is 1. I times I you get -1. The same with j by default 0 plus 1i. J times j, of course, you get -1. Now, if I type, for example, I equal 100, so this will override the default value. I is no longer square root -1, it's going to be 100. My command has a greater priority than the default value. Of course, you can define your own square root -1. For example, SM1 square root -1. It's going to be, you just type the complex number. Real part 0, complex part 1. Of course, that I is always not 100, but it's a complex number. This can be I or j. In this form, I or j is always square root of -1. You get none, not a number. Anything divided by 0, you get INF, infinity. Of course, in Matlab, pi has a value. Some numeric, only for numeric data, display formats. Format short, default of 4 decimal digits. All this while, we have been using this format. The output is always going to be 4 decimal digit or 4 decimal places. Format long is like double precision. You have 16 digits in this case. Of course, more decimal places. Format short E is exponent form, but the base is lower precision compared to format long E. 16 digits, 15 decimal places, so greater precision. Format bang is 2 decimal places. Format red, the results are always going to be into whole numbers. They're going to be in the form of ratios of whole numbers. Quickly go to the compiler, Octave compiler, CLC, clear screen. Format short. Format long. Format short E. Format long E. Format bang. Two decimal places, there's no rounding off. Lastly, format red. So I'm going to switch back to normal format short. just a quick overview of Matlab. Some mathematical function, there are a lot of mathematical functions in Matlab, just some of them. E power x, you have to type this using this syntax. Of course, in Matlab, ESP is just like C. ESP argument is a floating point constant. Log by itself is natural logarithm. You put 10 there, it's going to be log 10. Sine, cosine, tangent. The arguments here are all angles in radians. Inverse trigonometric functions will return the value in the angle in radians. Arcsine 1 will return the angle in radians. If you want the angles to be degrees, you have to put D here, D here, D here, D here, D here, D here. So the angles are all in degrees. Of course, square root, just like in C, SQRT, argument X. Quickly go to the Octave compiler. ASP 2.3, e power 2.3. Natural logarithm of, let's say, 2. Of course, I can type here ANS because this is actually stored in ANS. So it has to be 2.3 because these two are related. E power 2.3 is this value. Square root is simple, just square root. For example, 16. Of course, log base 10, you must put the 10 there. So 10 power 2 is 100. You can use the arrow key to go to the previous command. Trigonometric function, for example, sine 0.5 times pi, sine pi on 2 is fine, you get 1. If you want the angle to be degrees, 90, you must put a D there. Inverse, arcsine 1 returns the angle in radians. If you want the angle in degrees, you put a D there. So you return the angle in degrees. So that's the end of a quick overview of Matlab. So in the next lecture, chapter 2, we'll start with the proper Matlab programming. Thank you.